This is a good problem for JEE Advanced level. It involves the concept of capacitor, electrostatic energy loss in case of there is current flow through a resistor. It is given that there are two conducting plates placed at separation D. Each plate has area A and there is charge Q naught on one plate uniformly distributed. Now these two plates are connected through a wire of resistance R through a switch which is closed at time t equal to 0. What we have to find? We have to find charge on this plate which was initially uncharged as a function of time, that means t time after closing the switch, and also we have to find the loss of energy as heat in the time till current exists in this wire. मतलब जब तक यहाँ करंट है उस पूरी ड्यूरेशन में कुल कितनी यहाँ से हीट फ्लो होगी और स्विच क्लोज करने के टी टाइम बाद यहाँ पे हमें कितना चार्ज मिलेगा ये बताना, राइट। तो करंट निकालने के लिए वी नीड पोटेंशियल डिफरेंस बिकॉज वी नो दैट इन रेजिस्टर करंट इनटू आर इज वी। तो पोटेंशियल डिफरेंस कैसे निकालेंगे? किसी स्टैंड पर सबसे पहले तो ये रियलाइज कर लें कि भाई देयर शुड बी फ्लो ऑफ चार्ज, क्योंकि ड्यू टू दिस charge there will be electric field in this direction, and due to this field there will be a potential difference between this plate and this plate, and once we are connecting these two plates of different potentials, obviously there will be a flow of current. So we need to find potential difference here as a function of time, and that potential difference will be due to electric field. Let us assume that at time t this plate has charge q minus small q. Let us say this is q naught, not q. So at time t, suppose small q charge has come to this plate, so remaining charge on this plate will be q naught minus small q. So if we refer this figure, we can write electric field between these two plates as this much, because we know that due to charge q on a plate, both side field is q upon 2 epsilon naught. If plate is large, we will assume here large plate, so charge on this plate is q naught minus q, that divided by 2 epsilon naught, field will be in the right, and this charge field will be in the left, and that will be q upon 2 epsilon naught. So we will subtract this field to this charge, so net field will be this much. If we try to find potential difference, then obviously it will be field into distance between the plates. Potential difference will come out to be this much, where we have replaced epsilon naught a by d as C as a usual symbol for capacitance of such a system, where we have two parallel plates of area at separation D. So we have obtained potential difference. So IR, if the current at the instant is I, then IR equal to V. Using this relation, we can write I in terms of present charges on the plates, replacing V from here, and I is nothing but dq by dt, because in this direction I will lead to growth of this charge small q. So dq by dt is this much, v by r, and if we rearrange the terms, this much, this term below in the denominator, so that small q is on one side and remaining term on this side, then we can integrate it and limit 0 say is not q by t, it should be in general q, and time limit will be 0 to t, right. So we will first integrate it, we will get this kind of expression, and we place the limits and then take antilog, we will get this result. And simplifying, we can finally get a small q as a function of time. This is the correct expression where tau will be equal to RC, where tau is RC. And current can be rewritten as dq by dt, and if we simplify it, we will get expression of current as this one. To get heat loss, we will use the concept that I square R is the rate of dissipation of heat. So in time dt, this much heat will be dissipated, and we integrate this to get total heat dissipation, and we place I as this one, we will get this expression, and time limit will be 0 to infinity because I will be 0 at equal to infinity. We have to find the total heat loss till the current exists. So we integrate it, place the values of tau as RC, we will get finally this was expression of total heat loss, right? And if you can verify why this much loss will take place, I am giving this hint. Find here energy density initial field, and then calculate half epsilon naught E square, and then multiply that energy density with this volume A into D. You can verify that expression will be exactly this much. And why that energy has been lost? Because if we see finally here charge will be q naught by 2, then only field will become 0, potential will become 0, potential difference, then current will not exist. Once field becomes 0 finally, the energy density in this region becomes 0. So whatever energy was stored here, that has been dissipated, right?